Hello, everyone, and thank you for your patience for being here. I know this is not easy. This is a new system, and probably many of you are confused about how is this working and what is happening here. I mean, why I'm on a table on my own and everything. So thank you for being here, and welcome to this small scale LNG launch. We have been doing some networking on a table. Again, it was a lot of confusion at first. The system is new and we have to get used to that, but thank you for your patience. Let me explain how we are going to work now and what kind of things we are going to do. This is going to be a 1 hour session. We are 17 minutes in, and this is the welcome presentation. Of course, you have on your right 3 columns. You have a chat, you have a list of participants where you can see who is taking place in this forum, in this lounge, I call it. And you have a Q&A. When we start the presentation, in 1 minute, we will start a presentation. And in that case, you can fill up questions on the Q&A and you can press the vote for those questions and say which one you want to be answered first. Let me introduce myself. My name is Eduardo Pérez Orue. I'm the director of Small LNG. We are consultants and shipbrokers in small scale LNG shipping, very focused on this niche. And we provide training material and plenty of other services on small scale LNG shipping. Please subscribe to our newsletter if you want to receive more announcements about this type of events. Again, it's very new and we are very experimental, but I think this has a lot of potential for this industry where we are stranded in our offices and homes, in our countries at least, and we are going to be like that for a while. This has a lot of potential. We have 2 sponsors, Sener and B&R Consulting. Please visit their tables. The sponsors have their logos, and below they have a sponsors table where they will have people receiving you able to talk. So please go to their tables if you are interested in the services and to talk to them and talk too much. So grab a coffee, relax, listen to the presentation, do ask some questions in the Q&A. And the program, as I said, is we've been doing 50 minutes networking and learning a little bit about the system. Now we'll have a short presentation, 50 minutes presentation from our main sponsor, from Sener in this case. Ask questions on the Q&A. And today's presentation is going to be by María Ángeles López Castejon from Sener. She's a naval engineer in the industrial division of Sener, and she will be talking about Semi-Ballastable Barge Transporter, SBBT, and their project in Venice in the Adriatic. So please, María Ángeles, if you can join the presentation, hopefully everything goes fine, and she will be joining me, switching on her camera and her microphone. The microphone, don't forget the microphone. And then I will let you present. I will switch off this for now, and I will disappear, and good luck.
Thank you. Hello, welcome everybody. I'm going to explain our project. It's a semi-ballastable barge transporter. I have only 15 minutes, so we'll start. Okay, the unit has 2 parts. The first part is the cargo unit. It's a LNG bunkering unit. It's a barge non-propeller with a 4,000 cubic meters of LNG store capacity. It has 1,000 cubic meter per hour LNG unloading capacity, and also it has 1,000 cubic meter of marine diesel oil store capacity. In the barge, it's non-propeller, we have only an emergency generator. Why? Because all the electricity power goes from the power unit, that is a tag. This tag, that is the power unit, is gas fuel and restricted navigation with a buoyed propeller and a capacity of LNG of 50 cubic meters only. The class society is RINA. The flag is Italian. The following is the notation for the combined unit with unrestricted navigation, and the following is the notation from the barge, because it is gas fuel, unrestricted navigation, score, supply, resquire, Okay, the current status of the project is under construction in Italian shipyard. Well, I'm going to speak about the LNG cargo system. We have 2 tanks of LNG, type C. Also, we have ship-to-ship transfer system, gas detection, fire detection, emergency shutdown system. For inner gas system, we have 1 nitrogen generator with a vessel. Also, we have top filling and vent system. And for the boiler management system, we have LNG subcooler unit. The autonomy of the ship is 20 days without opening the relief valves. And the configuration of the manifold is liquid, vapor, liquid, and MDO according with the rules, the distance between the flames. We have 4 fenders for protection during the ship-to-ship maneuverability, and 2 pumps per tank. One is the chilled pump, feed pump, a spray pump of a capacity of 15 cubic meters per hour, and the other pump is the cargo tank pump with a capacity of 500 cubic meters per hour. The gas handling system and the auxiliary equipment has been designed to perform the following: cargo tank drying and inerting with nitrogen from shore, cargo tank purging with vapor from shore, cargo tank cooling down with liquid from shore, cargo loading with the pump of the terminal, cargo tank pressure maintenance, cargo cooling down by cooling of LNG by refrigerator, unloading to shore or to ship, cargo tank warming up with hot gas from shore, cargo tank gas-free and ventilation with nitrogen or dry air from shore, and cargo piping purging with nitrogen from barge or shore, and cooling down of client with LNG. Well, for boil-off control, the tank pressure may be controlled by subcooling liquid, LNG, in the refrigerator system. The capacity of that subcooling unit is 500 kilograms per hour. Alternative, the boil-off can be contained in the tank, and it's important to control the filling limits. The pressure of the tank of the vapor phase may be controlled by streaming using the chilled feed pump. In the ship-to-ship transfer system, we have 2 liquid hoses connection and 1 vapor hose connection. The separation process of the transfer system will be activated automatically by detection of exhibit vessel drifting or manually by push button. The transfer system consists of the following main components: dry connect disconnect coupling, emergency release coupling, power off and control unit, vessel separation detection system, ship-to-ship cryogenic hoses, and hose saddles. The TAG is a dual fuel tank. It has a LNG tank of 15 cubic meters, 2 gas valve units, 2 main engine dual fuel, 1 auxiliary engine, 2 sub-generators of 1,100 kilowatts electrical kilowatts, 2 Void propeller, 1 LNG bunkering station, 1 emergency generator, and the batteries and battery charger according with the rules. Okay. Technological challenges of this project is the innovative position, maneuverability and seakeeping, electrical and mechanical joints. Okay, the first one. Well, the innovative position of the power unit with respect with the cargo unit made it difficult to comply with the rules. But it's the first in the history puller in a state of pusher for a power unit. The second challenge was maneuverability and seakeeping. There have been key points during the design due to the requirement of sailing through Lagoon Venice. There have been model tests carried out in waves in order to analyze the force occurring on the coupling between the tug and the barge together, with head C, stern C, and transverse C. I'm going to show you the model test. Yeah. What? Okay. And you can see some example of our model test. Several model tests were also necessary. Calm water model test for resistance and propulsion, a test for tug to get its towing curve, for the barge to get its towing curve, and also for both together to get their towing curve at speed towing prediction. For this, we make a model with a scale of 1 to 130. For example, if the tug has a length of 35 meters, the model has 2 meters, and the same scale for the barge. Okay? The last challenge was electrical and mechanical joint. The short connection for electric interconnection between power unit and cargo unit will be composed of 2 different parts, one for power unit and one for communication, control, and alarm. This short connection will be placed in starboard of the frame 14 in the tug, the power unit, and the frame 150 in the cargo unit. Near to the frame 150 in cargo unit will be placed a manual crane for help to connect and disconnect this interconnection, and a reel to store the cables when the interconnection is not used. The mechanical joint device consists of a pair of port and starboard pins installed in a structural support model on the tug. The position of this joint was one of the critical points in the design, and it was a key point for the final arrangement of the tug and the barge. We had to make several analyses, structural analysis, in order to make sure this connection. You can see here how is the pin that has a to the head. Okay, you can see more that is fixed in horizontal axis, but the tug can pitch. Okay. And competitive advantage. Well, this is the first puller unit in the world, the first LNG power buoy tug in the world. It's a combined unit designed with generated wave reduction and for unrestricted navigation. There are a lot of pushers in the world, okay? But in our case, it's the first puller unit. You can see achieves greater visibility with the corresponding reduction in steel weight and improved maneuverability with their position. This is the first LNG power buoy tug in the world. What happened with the machinery? Normally, in tugs, we have a conventional subline, and the propeller is outside the engine room. But we need to pull the barge, and we need more power, so we can to install a void. What happened that we don't have space, but we get to install dual fuel engine with void, with all the equipment that needs a gas fuel system for dual motors, dual engines, tank, a gas valve unit, everything, and to choose the power that we need to pull the barge. And the last competitive advantage is that remember that is unrestricted navigation. During the model test, we have waves of 7 meters of length. In order to make sure that the combined unit can sail in unrestricted navigation. For this, CFD calculations, seakeeping and maneuverability analysis have supported the ship's design to reduce the generated weight. Remember that this unit was developed for the Lagoon of Venice and was one of the more exigent required that the waves reduce the waves. Okay, well, 2 minutes. I think that we choose it. Thank you very much. If you have some questions, because I'm probably very fast in my conference, I'm going in my sponsor decks.
Sorry, I had too many things in front of my screen. I couldn't. So thank you very much. We have some questions here, and as Maria Angelis was saying, afterwards, you can find her in the sponsors table for Sener, and you can ask more questions right to her. So the questions that we have right now, is there a commercial reason for this type of design? I mean, apart from the technical reasons, any commercial, purely commercial?
Yes, we know that the owner has their market and their commercial proposal. Yes.
Yeah, but any reason why that pool barge and not for commercial reason, or is only technical?
No, it's technical, but well, this design, one of the advantages of this design is that you can use another tax, for example, if the barge is ready for this tag, and then the commercial could be faster.
Mm-hmm. Okay. Can the power unit work as a general purpose tag when not in use for moving LNG?
Yes, the tag. No, the tag is independent, and they can remember that the notation is rescue, is firefighting. So if you don't have the market, or if you don't need to make bunkering, the tag could be done another thing.
Okay, perfect. When will this be operational?
When? Well, now is in the shipyard building, probably next year.
Okay.
It's finished.
Okay, so it's well advanced. The construction is well into. Okay.
Yes.
Okay. Can the STS be done underway or only when the ship is moored?
Sorry, what?
Can the ship-to-ship transfer be done underway or only when the ship is moored? Can be done in the middle of the.
Well, can be done, but the flag and the authorities has to permit it. So, okay. But in the seakeeping study, technically, yes, it's possible. During we make several studies with all the ship-to-ship condition with a bigger ships, a cruiser, a smaller, and it's possible. Now, if the flag allow it, I don't know.
Okay. Can we adjust your design to existing tags we have?
Yes. Well, I have to study the tag in order to see the structure, the power, then we can adapt it, the barge to this term of the tag. You have to install the ping and several things, but one of
in
the
some
most
cases, in some cases, might be possible if the tag is the right tag.
Yes, we have to make the study of this tag, but it's a possible.
Okay. What sea state can this system work in? I mean, where can this work? Anywhere in the world?
Anywhere, because it's unrestricted navigation. So all the structure, all the equipment, the power, all the test trial will be done for this unrestricted navigation.
And one question from me related to that one. Is it possible to build this anywhere in the world? I mean, just
yes.
most yards is a relatively simple construction. It's not a complex unit.
Yes.
Okay.
Unrestricted.
Can you hold the barge alongside the vessel being bunkered using the tag only and not mooring lines? That's basically...
sorry, but I don't understand the question.
Can you hold the barge alongside the vessel being bunkered using the tag only and not mooring lines? Is what you answered before. You don't need to be on the shore.
Okay.
I understand, no?
Okay. The barge, in this design, the barge need the tag, okay? Because all the electric power came from the tag to the barge in this design. So for bunker from bunker operation, the barge need the tag.
Okay.
But in another design,
but no, you can do it without mooring lines. You don't need to be close to the shore. But
no, because it's no.
Okay, I think.
Yes.
Okay, what size LNG vessels carriers can STS down from the barge? What type of what size of LNG carriers can you bunker with this type of units?
Well,
how big?
We have a study to make ship-to-ship two bigger cruiser. So between 300 of length, 200 of length, and for a smaller also. So we study bigger and smaller tanks, but the Defender is ready to the bigger one to the smaller one.
Okay, but the design can be adapted to almost any size, basically.
Yes. Okay. It's important all the place near to the manifold and the position of the manifold, but without any problem.
Okay. How does the system compare to the VT Halter Marine Articulated Tag Barge System QLNG 4000? That is the one being built in the US for Shell, if I'm not wrong. Is a push barge that is being built in the US.
Yes, I see.
Right now, it's based on the American tag push barge designs.
Well,
for what I know,
no. the history of this project was different. Owner came to Sener. We was talking about what they need because there is tax marker, and we adapted the bunkering unit for the owner because the owner has a lot of tax in order that your marker and your commercial.
Okay.
So we don't know thinking about American or not. We adapted to the owner.
I think the biggest difference might be that this is a pull barge, you said, and normally the Americans are push barges.
Yes, because thinking it's better to push for better visibility, better maneuverability. Well,
Okay. A few more questions. Can we adjust LNG capabilities to this model? I'm not sure I understand. Can we adjust LNG capabilities to this model?
Okay, perhaps is about the capability of LNG. With this dimension of the barge, now we have 4,000 cubic meters of LNG. Well, with this dimension, we have studied to increase the capacity of LNG until 7,000 cubic meters. So we can adapt it this design. Also, another client asks us about more capacity, and we can modify some little bit the design, but we can choose more capacity.
Okay. Thank you, Maria Angeles. I think it was great. Now, the rest of the questions, sorry, but not to keep the whole conference staying here.
Okay.
The rest of the questions you can ask to Maria Angeles in her table, in the Sener's table, top right in the conference room. And now let me finish with a little presentation of what else we are going to do today, and then we go back to the meeting. Okay. Thank you, Maria.
Thank you, Eduardo.
Cheers, bye. Now, let's continue with this. We are going to go back to the networking now, so you can talk to other people. You will be divided into tables. Also, there are 2 floors. Some of you might be on the 2nd floor. You have the elevator on the left. Please go down to the 1st floor because we are not that many people as we expected. So everybody is on the 1st floor. Come and join a table. You can join any table you want. Please double click on the table. And you can also double click on the tables of the sponsors, and then you will go to talk to them. So please do that. Feel free to network with other colleagues. Thank you very much for your patience. Anything you need, please contact me. And if anybody's interested in sponsoring one of these sessions in the future, again, it's a new system, but I think has a lot of potential. Thank you very much. Back to the conference tables. Stay there. We'll be until we spend 1 hour in total. So see you.